2 columns of slide 3.
Yes. Yes, so we just finished that. So now you've just seen more of the details behind the propositions. Okay, the methodology then, as I said, the study population is limited to early stage projects, those within 2 years after the first release, to control for project maturity, only developer targeted and not user targeted. And also, as I mentioned before, we exclude corporate sponsored projects. We use SourceForge as our primary data source, the web pages of SourceForge, as well as 2 research databases. The one most important one is from the University of Notre Dame. Greg Mady and his associates have created that, and they basically take monthly dumps of SourceForge and make it available to researchers, and that was certainly a very valuable source of data. So, using those data sources from SourceForge, we basically selected a sample frame of projects which met these study population criteria, as well as criteria for data availability and integrity. That resulted in 160 projects. And you do have in your handout a profile sheet, which is from the manuscript, that profiles that group. And it looks like a pretty reasonable distribution of projects. I won't go into the details with you that after if you want. So for those 160 projects, then, we extracted data from these sources using database queries. We compiled the data with spreadsheets and created the social network variables using the UCINet social network software. Again, the social network variables there's some examples in your handout. The manuscript describes them. Basically, for closure, we use the measurement of density. For bridging, we use the measurement of membership degree. And for leader centrality, we use what's called class centrality. So again, we can get into more detail later, but that's basically what we're doing at this stage.
So you got extra details in these extra slides.
Yeah, there's each of the 6 social network variables are described in the extra slides, and I can get into that after. So, data analysis, we did the required preliminary work, we did normality testing, and we did log transform the dependent variables. So that was necessary, and it seemed to provide a good solution. In our outlier assessment, we eliminated 17 cases, so that's what ended up with 143 that were passed on to regression. In the factor analysis, we actually had a total of 6 community success variables, including trackers open and trackers closed. Those 2 tracker variables were eliminated, and I can give you some detail on that as well. But basically, that's how we ended up with 4 success variables: code commits, software releases, software downloads, and page users. In the regression analysis, then, we defined 24 hypotheses, and these are combinations of the 6 social network variables. Those were those 6 propositions I just went through, crossed against the 4 success variables. So each of those pairs is one of those hypotheses. And in your handout is the full list of the hypotheses if you want to just scan through that. So for each of those hypotheses, we did the regression analysis, we did the required assumption testing, found the major problems. We did control for group size, number of members in the total group, number of members in the core subgroup, and even conversation volume in terms of the total number of posts. We wanted to be sure we weren't seeing the effects of total conversation volume, as opposed to, we want to see the effects of the structure of the conversation. So that's why we also control on conversation volume. And we do apply both linear and quadratic regression. The quadratic is what is used to test for those inverted U's, and it basically involves squaring the independent variable. And there's an example in your handout of how that works, and we can sort of talk about that. Okay, so now the results, the 3rd column. So getting into what I described at the beginning. So I'll do these for each of the 6 propositions. So for the group closure proposition, which has 4 hypotheses again, those are your 4 success variables. We had projected an inverted U-shaped relationship. What we found was negative relationships.
So now you're taking us through the last 2 columns.
Now yes. Basically the last column and comparing it to the middle column. All right? So, these the green? Oh, okay, I'm sorry. The 3 stars, that uses the traditional method of P values. Yeah, so 3 stars is 0.001. P-value significance. 2 stars is 0.01, 1 star is 0.01.
We were losing.
So the green are the two activity variables, and blue, I guess it's blue, are the two output variables. So you can see in terms of activity, very strong negative results. Also negative results for the output, not as strong, they're not even significant, although they were getting near significance. And again, we were surprised that there was no positive result for any of these, even at the low level of density. The core closure then, again, we found negative results. 3 of the 4 were negative, although they weren't as strong as in group density. You can see only one here had a single star, which is a 0.05 level, and the other 2 were near significant. So we did see the negative, but not as strong, suggesting that maybe compared to the group closure, we maybe are seeing some positive benefits. And say within the core subgroup, you do need some level of interaction, but it's not enough to have any kind of a positive early signal. So it did moderate the negative, but it really didn't produce any kind of positive effect.
Does this mean that basically the less people talk to each other, the higher the success rate?
Exactly right. The less they densely talk. I mean, there is conversation. Well,
let's hold that to the
that's going to be a long
That's
discussion.
a long discussion.
Yeah.
That's a long discussion. Let's not do that.
We will get into the next talk. You're in trouble with this. Okay. Now, we did find this U shape, and the quadratic regression also finds U shape. So it's this kind of shape. And actually, if you look at the scatter plot, there's really only probably 10 or so projects that cause a little upturn at the end. And we suspect that these are qualitatively different. These may be individuals that actually know each other. So in some respects, it may be kind of a virtual team that just happens to use SourceForge to get some work done. So in some respects, we think it's a different kind of animal, but we don't know for sure. We don't have access to the data to find out. That could be subject for future research. Now, the peripheral two-mode closure, this is the closure between the periphery and the core. Notice here, we have no significant relationships. One is negative, but it's quite weak. So here we're saying, you know what, we thought we'd see some positive benefits attached to this core periphery connection. And considering that this is really kind of a subset of closure, so we know from the other slides that closure seems to be bad, but in this case, closure at least is non-important. So maybe that's the offset of some of these positive benefits. So what's happening with closure? Why is this? And basically, if you step back and you say, look, let's understand that this open source process involves assembling software from these many incremental contributions by these people who independently kind of self-manage, they choose their own tasks, work at their own pace. We knew ahead of time that open source tools do reduce the need for interaction, but we didn't realize the extent to which it actually apparently minimizes the required level of density, and that the smoothly functioning, this bizarre-like process, for it to function smoothly, you can't have that kind of interaction. You can't have a lot of crosstalk. You can have one-on-one talk, and so that's what we'll get at. It's not about total conversation volume. It's about how many people have to get involved in conversations. That's what density is about. That's what closure is. So what this is saying is that it's really this host platform that is minimizing the need for density. We already talked about the modular software design as part of the platform, but some of the other explanations that came out of this really began, the notion of the platform is more than just the modularity of the software. It's really kind of the whole, think about it. When you're participating in one of these project communities, you're sitting in front of a screen. So what is in that screen? Well, basically, when you go to the project, there's certain affordances you have, and there's certain constraints. And that's basically what the host platform is, a set of affordances and constraints. So it consists of the software, first of all. The source code is there. It has a certain design to it. There's forums. There's documentation. So, for example, if there's good documentation, there's no need for a lot of cross-discussion. If there's not, there's going to be some problems. If there's good, clear rules. So rules are part of the platform. It's the whole thing that you see when you come online. So good rules, no problems. Problem with the rules, you're going to have controversies and the need for these cross communication. So basically then,